All right, so I've got a blank design document here. And in this document, we are going to build a basic chassis. So we're just going to build one side of a chassis. And the process we're going to go through is we're going to put the structure down first. Then we're going to add our bearing flats, followed by axles, gears, and wheels. We're going to do it in that order. And we're going to do that for each wheel on the chassis because this chassis is going to have two wheels. So to start things off, I'm going to start by grabbing my structure. So in my Vex project here where I have all of my metal, I just jump in here, grab structure. I'm going to go to C channel, and your formatting might look a little different than mine, but it's important you just have it organized somewhere. And so I'm going to grab some aluminum 5 by right here, 5 by 35. That'll work. Okay, now I just have to click, drag, and drop. Okay, so I've dropped it in there. I'm going to go ahead and move this around here a little bit because I don't know, I just like this orientation there. I'm going to put that part right about there. I'm going to hit enter. Okay. Now this is going to be my very first part. So everything else is going to be kind of linked off that part. So I want to ground it. And what that means is I'm going to lock that one into position. So to do that, I'm going to go into my browser. I'm going to right click and I'm going to go to ground. All right. And so now this spot this metal piece is locked in. So like, for example, if I grab it and move it around, it won't move. If I bring in another one here, again, I'm just dragging and dropping from the data panel. I'm going to bring that over here. I'm going to rotate it to 90 degrees. There we go. Looks good. Notice I can just click and drag and move this around. That's kind of the difference between a grounded part and a non-grounded part. So it's always good to have one grounded part so that positions aren't moving all over on you. All right, so now we need to start putting them together. And so this is probably the most important part of the video. To attach two pieces together, you use the joint command. So joint can be found right here. You can also press the J key on your keyboard. I tend to use the keyboard shortcuts all the time. Pressing the J key works really, really well. So I'm just going to press J, and it automatically brings me into joint mode. Now, in joint mode, the first selection is going to be your piece that moves. The second selection is going to be a piece that it snaps to. So it's always important to select the piece you're moving first. So here, I'm going to move this other piece here. I'm going to select right here, and notice we have all these little white spots pop up. Those white spots are anchor points that you can then match your joint to. So I'm going to select that one right there, and it does take some really precise mouse movement, so make sure you zoom in when you do that. So I've selected there, and then I'm going to come over here, and I'm going to select the same kind of spot here. So we selected the backside here, so I'm going to select the exact same spot in reference. And so the reason I do that here is so that when I flip it over, so down here I'm going to click the flip component, they line up perfectly. And like if I go like this and I orbit around, notice those holes line up perfectly. That's what I want. So when they line up perfectly like that, now I can start moving my joint. Now, when I build a chassis, I need some space there. So what I'm actually going to do is I'm going to spread these apart. I'm going to spread these apart 3 inches. So you can just drag it until this gets to 3, or you can just go in here and put 3 inches. Okay. I'm doing mine in inches instead of meters here. So there you go. I've got two pieces here. They're linked together. So now notice if I click and drag, this one doesn't move at all anymore because it's locked into that grounded part. Okay, so the next step here, we need to go and grab some bearing flats. So I'm going to go to my motion, wrong one, other motion. And I'm going to go to shaft hardware. And if I let it load and scroll down here a little bit, I will see my bearing flats. That's my narrow bearing flats. We want the standard bearing flats. There they are. Okay, so I dragged those in. Okay, I've dragged one in. There it is. That looks good. I'm going to go ahead and make a couple copies of that. So if I just select the piece, Control C, Control V, I can now just make a few of those copies. I'm going to go make 1, 2, 3, and so I have a total of 4 bearing flats, and that's going to be perfect. Now, when I put these bearing flats in, I'm going to take one and mount it to the metal, and the rest of the bearing flats are all going to be referenced from that first bearing that I put in. And there's a reason I'm going to do that, and I'll show you why. So let's go ahead and start with this first one here. I'm going to press the J command. On bearings, there's a really good spot to joint to. So notice how you have these little feet here. These feet here are designed to sit inside of the square slots. So what I usually do is I select this flat piece here, that anchor, because I have to joint it to something else that's flat. And so in this case, I'm going to joint it to this opposite chassis over here. And so I'm just going to go ahead and pick a random spot here. Let me go ahead and minimize this so we can kind of see what we're looking at. So I'm going to go right here in the middle. I'm going to joint it to this spot right here. And again, zoom in to help you out. So if we notice here, okay, it comes in. I don't want my bearing like that. I'm probably going to do it horizontally. So we adjust the degrees. And now we need to get the holes lined up on the back. So I rotate around to the back side. All right. And we can then adjust this left and right until the holes line up. Now, if it doesn't seem to be snapping correctly, like maybe it just seems to be off, you can't get it perfectly aligned, zoom in so you can really get fine movements on your piece. And there should be a little bit of tolerance there, like a little bit of wiggle room, and that's by design. So what we have there is perfect. So we're going to hit enter there, and we're good to go. All right, so now that bearing flat is in place, so now it's time to put the other bearing flats in. So we got to kind of remember, so here we can kind of see where the joints are. That joint right there is going to be one we keep coming back to change things. So here we go. So now we're going to do our next one. Now on the next one, instead of doing the flat back, we're going to do the hole on the front here. So I'm going to do J for joint. I'm going to zoom in on this one, and I'm going to select this hole, that center of the hole there. And now it's really nice here because what I can do is I can go and select my bearing here. Let's go. There we go. I can select right here. And I can get it all lined up perfectly so it's perfectly aligned. So I know that those holes are going to be lined up. And then again, all I have to do is scooch this out to the width of my channels, which I know is 3 inches right there. And if I look here, it's all perfectly lined up. Everything's in the right spot. It's right where I want it. So I hit enter, and we're going to do this a couple more times. So again, we're going to do J. We're going to rotate around. If I haven't mentioned this before, some good commands to know. That middle, you really want to mouse with a scroll wheel that you can use as a third button. I'm using that button to actually pan and rotate. So if I just click, so for example, if I just click it and pull, that allows me to pan. If I hold shift and click, it allows me to rotate. All right, so I went to that one there. And this one we're going to do a little differently. So this one I'm going to flip it because I want to put it on that opposite piece there. I'm going to rotate it to 180 degrees. And I'm going to move this down. I'm going to give it 3 holes of space there, I think. So now this one we do need to go line up. I do need to go line up on the back side because I haven't lined up with the holes. It looks like I actually got that pretty cleanly. It's really close. It's probably close. Oh, okay. So here you can kind of see it's outside of it a little bit. So we do need to slide it over just a little bit. There we go. It looks pretty good. My classroom lights turned off on me. Bear with me here. All right. So we've got our piece in there. Excellent. So now we're going to do our last bearing flat here. We're going to join it up to, and this one here, I'm going to join up to this. So I'm going to take this bearing flat. I'm going to joint it to this one here. So you got to select my hole there, rotate around. Almost like that one there. And again, it's a lot. It may seem a little tedious. You're just doing the same thing over and over again, but this is really no different than building a robot with parts. You would do the same thing with parts. Okay. So here it's just you don't have to worry about not having the parts available. You don't have to worry about running out of parts. You don't have to worry about cutting things. You can do this all in CAD. All right, so we've got these all there. Now, why did we do the bearing flats first? Let me kind of demonstrate that piece here. So if we kind of come back, this joint right here was the one that we originally mounted that to the metal. So if I actually go in and I edit this joint here. So I go right click and I do edit joint. I can actually move that guy around. So let's say I move it down 1 inch. Notice everything else moved 1 inch as well. So if I build my entire wheel and gear assembly to the bearing, reference that, I can actually move the entire assembly there without changing every individual piece, which is super handy. So it's really kind of important that you think about the sequence of how you joint pieces together and what you reference them to, especially if you need to change them later on. All right. So now we are ready to add some more parts. we are ready to add some axles. So I'm going to bring in some 12-inch axles here. So I'm going to bring in 2. So there's 1. I'm going to go ahead and move this out of the way. Enter. I'm going to go ahead and bring a second one in. We're going to bring it over. All right, and now we're going to joint those in. So I use J. I'm going to select the end here. And again, this is where things get really, really nice. By adding those bearing flats in and getting them lined up, now all I have to do is select the hole that I want to go through. So I want it to go through this one right here. So I'm going to joint it to that one. And now I'm just going to slide it around a little bit to where I like it. Because I'm going to have a little bit extra here, which is kind of to be expected. Okay, so there we go. So this one's going to be where my wheel is. And that looks pretty good. Now, there is one change I'm going to make here. If you notice, we have a motion tab here in our joint command. So the motion tab allows us to change what kind of things happen. So for example, if I go to revolute, that's going to allow the axle to spin. And so there's a lot of different options there you can play with. But if we think about it, we want axles and wheels to be able to spin because then we can actually animate the motion. So we're going to hit OK there. So this guy, if I actually zoom in here and I grab an edge, notice I can rotate that. Oh, so nice. So we can actually mimic, or we can actually simulate motion on our robot before we even build it, which is pretty incredible. All right, we're going to do the exact same thing here with our other axle shaft. So we're going to do J here. We're going to select there. And we're going to go ahead and joint this guy in. All right. So I want to have 1, 2, 3, 4, 5, 6 holes between. So I'm going to do that one there. And again, so now notice it automatically did the revolute option because that was my previous choice. So it's going to keep using the same joint command you used over and over again until you tell it to do something different. So we'll pull that out a 1/2 inch as well. All right, so now we have 2 axles that spin. So now let's go jump in and let's add some gears. So I'm setting this up to be a 84 to 64 tooth gear ratio, which should give a 4-inch wheel about, I think it's 280 RPMs. I probably wrong there. Maybe it's 333. I'd have to do the math again to be sure. But anyways, I just wanted to do that particular ratio for fun. All right, so here is my 60-tooth gear. So I'm going to drag and drop that in. And here is my 84-tooth gear. Actually, well, I got to hit, let's move this around a little bit. Let's go over here. And then I'm going to drag my 84-tooth gear in. It's going to put it right in the center. So drag that over there. Enter. All right. Now, because we made the axles revolute, we don't have to make, we're gonna not do a revolution on the gear. We're actually going to make that static to the axle. So we're going to do a rigid joint here. So we do joint. All right. So I'm going to go all the way into our axle here. And I'm going to grab this one piece here. Okay. And then I'm going to come over to my axle. Now this part is a little bit interesting here, and you got to be looking for the right thing. On the axle, there's always a midpoint. So right about there. So that's usually the spot I like to join it to, unless my ends are available. And now notice it's automatically doing the revolute. We don't want revolute. So we're going to go to motion here, and we're going to change this to rigid. Okay. And so now it's right where we want it, or at least it's not right where we want it. We know it's going to be connected. So now all I have to do is change my axis here. And if I look here, pan down. Again, a lot of assembly is just moving around and navigating the space. That is exactly how I want it. All right, so the only thing I have left to do here is scooch it into its spot. So I'm going to go ahead, I'm going to put this kind of close to my metal here. And that looks pretty good. That's about where I want it, so I'm going to hit enter. Okay, and so now I have my 84-tooth gear right where I want it. Okay, so now I'm going to joint the 60-tooth gear. So I come over here. Again, same concept. We're doing a whole lot of joining today. And this is why it's a really critical skill to have when you're doing an assembly, is you want to be able to do joints. All right, there's our square. We're going to do that. And we have to rotate it. So there we go. And we're going to slide it over. Now here we're gonna, it looks about to be the same there. I'm gonna zoom in here, make sure I get it right. All right, so I can scooch over just a little bit. That's close enough. And we'll hit OK. Right. So that gear turns, that's all well and good. Okay, let's add our wheels now. So I go back to motion. I go and find my wheels. So wheels are at the bottom here in W. And we're going to add a 4-inch Omni wheel onto this one. So we're going to go down to 4-inch Omni wheel. I'm going to drag that guy in. Okay, drag that in. And I'm just going to hit enter. Now, we're going to have a little bit of a problem with this particular thing. So if I go into my design here, notice all these are squares here, or cubes, excuse me, but the wheel we just selected is not. So if we actually open up this window here to hit the drop-down arrow, here you can see all the different pieces that are inside that assembly. So this is actually a compilation of components. All right, so there's a lot of pieces there. Whereas if I look at, like, for example, the 84-tooth gear, this is really just a body. It's one body. So we have a bit of a difference there, and so we have to do something different. So here we want to keep this all together. If I try to joint this right now, it's only going to joint the individual component. We don't want to do that. So what we do is we right-click on our device or option, and we do rigid group. So rigid group, we're going to capture position. It says, okay, there's 99 pieces inside and 99 components. We're going to keep those all together. We hit OK. So now when we go to joint this guy, so I'm going to select here, and we're going to put this on the 60-tooth gear axle. So again, we're going to go out to here, and we're going to select our middle point there. And notice it looks like it just brings that center insert. It turns out it actually does more than that. But so if we hadn't done the rigid group, it would leave it right there. Okay, so we don't really want that. So what I'm going to do, I'm going to move this into my middle here, where I think it should go. I think I'm going to need a little more space than that for the Omni wheel. Right there. And we'll hit OK. Now notice the whole wheel comes with it. If I hadn't done the rigid group, only that middle piece would have came, which would have been a real problem. So it's a good thing that we didn't have to worry about that. All right. So we got that on there. Okay, so not too bad. Now, if we're looking at this, we're probably thinking to ourselves, hey, two things. One, I want to put a motor on next. Okay, we got to do that. And two, we have these really, really long axles. So those are the last two things we're going to do. So let's grab a motor here, and we're going to use a V5 smart motor here. So we go to Motion Electronics, and I scroll down here. I have V5 Electronics, and we can go find a smart motor. And a smart motor is very similar to it's very similar to the Omni wheel, where we have to make a rigid group. All right, so I'm going to scooch this over here. I'm going to move this into space, and we're looking pretty good there. So I'm going to hit OK. All right, now let us know. Let's do that. Okay, I'm going to undo what I just did there. All right, now we're going to attach this guy to our piece here. And so here, we're actually going to attach the motor directly to the bearing. So I'm not going to attach to the axle. The reason I'm not going to attach to the axle is that axle can move. I don't want the motor to move in real life. I want that motor to be rigid in its spot. So all we have to do is first we select our motor. So again, notice that's an assembly. So we click on it, right click, we do rigid group, and we hit OK. And now we can do the J command. And let's go ahead and do this outside one here. So we're going to select that center there. Okay. Now this is a little bit tricky, and I need to find a better way to do this. But right now this is the best I've got. So I'm going to joint this to the bearing just for the sake of argument. I could do it to the metal as well, but I'm just going to do it to this central hole because I have it there. It's nice. You probably wouldn't do this in practice because these feet here are going to run into. They're going to run into the this guy here. So we can actually do it either way. If you wanted to do it to the bearing, you just link it to the middle. If you didn't want to do it to the bearing, like let's say if I wanted to put it on this side, I would link it to one of the edges, and then I just have to adjust it. So let's go ahead and do it to over here. Let's follow best practice and put it not on the bearing. Okay, so notice there it just brought that insert. So if you've ever taken a smart motor apart, there's these little standoffs with threaded insides. That's how you actually screw your screw in. That's what we have there. So I'm going to go ahead and flip this guy because I want it on the outside. And then I'm going to shift this guy over a little bit. And we kind of need to get an eyeball inside there. And so this is where it's kind of hard to see. Actually looks pretty good. All right, so it looks good. So we're gonna hit OK. And now notice it brought it over and it put it funny. And the reason it does that is because it's hard to see the orientation of that standoff in there. So one of the things you have to do here is you place the motor, and then you got to kind of guess. You got to guess, check, and see like, okay, where do I need to rotate that? So we need to rotate that pretty badly to the right there. So we just go to our joint. We just need to edit. So we come over here, joint, you edit joint, and we just rotate this. So I'm going to guess, let's try going to 0 here. Because it was at 180, it was quite a bit off. All right, so it looks like we need to go up a little bit. So come on. So escape there, go edit joint. So let's go, I'm going to go to about 15 degrees. Let's try 15 here. Okay, getting closer. Might be 25. Thankfully, you don't have to, there's only, for a competition robot, there's only 8 motors that you'd be putting on. All right, looks like we need to go to 30 degrees. So you don't have to do this too many times. And you'll kind of notice that there's a pattern. It's usually like the same degree measure every time. And there it is, 30 degrees was our magic number. Okay, and so now we have a motor on there. All right, we don't have the axle going through yet, so that might be something we would change. So for example, all right, I want to go back and change that. Well, all I have to do is go to, let's see, we jointed the axle behind our gear here. There's our revolute joint. So if I click on that revolute joint, I right click. All right, let's see. So notice it also holds it down here in the bottom in your timeline. So we can do edit joint. And so we can actually increase the slide here. So maybe I'm going to give it a full inch. Hopefully that's in the motor at this point. Yeah, that looks like it's in the motor. So now I know I have plenty of slack on that axle to build this. Notice it did move the gear, so we need to adjust. I believe that's this joint here. So we need to go edit, and we need to slide this back. It looks like we need to do that a little bit more there. So another, we'll go 4 inches. There we go. Okay, that looks pretty good. Okay, so now we've got these pieces together. It's coming together. It's starting to look like something. We have an idea of where our spacing would be if our spacing is right. And so now what we're going to do is we're going to trim these. So these axles are too long. So this is the kind of the last thing we need to do. So I can go ahead and close this. So whenever you want to trim an axle, or you want to trim any part at all, if you want to make it smaller, all you have to do is open up your browser, and the first thing you have to do is you need to select the 2 parts that you want to, select the parts you want to cut. Most of the time you do this individually, but we're going to right click here, and we're going to click break link. So what is currently happening here is Fusion is going out and grabbing the file from somewhere else and essentially linking the 2 together. So it's saying, hey, I'm using this file here. If I want to make a new part or a custom part, I need to break that link so that I can then make the part. So we hit break link here, and then we are going to do a 2D sketch, and we draw a sketch right on the end of our piece. And so I'm going to draw a circle here. So right from there, I drag it out. It does not matter the size. You do not need to dimension it. You just need to make sure it's bigger than the object you're cutting. So then we hit finish sketch. So then I'm going to rotate to the side a little bit so I can see things a little bit better. And now if I use the E command, which is extrude, I can select my circle there. Make sure you select the inside one because it's always going to make 2 sketches there. And then you just drag it in and you cut it. So we're doing a cut command. And so I just bring it there and I hit enter. And boom, it's good to go. It's been cut. Do the same thing over here. We could have done that in one sketch if we wanted. I tend to like to do things, like when I'm cutting pieces, I like to cut pieces individually. Not much different than if I were to do it in real life. Finish my sketch. Zoom out. And we cut. So extrude. Click here. Click my inside one. Click my outside one. And cut. And I hit enter. And now we have a shortened axle. And that's it. We've made a half of our chassis. So now try building the other half of the chassis on the other end of your structure.